Hello, geometry students. I am making this video in a house that's surrounded by snow, or at least ice, or maybe cold grass. But it is our second digital learning day of the school year, and we have another one tomorrow. So I wanted to touch base with you and make sure you got the notes from today and understood them to the fullest and could do the assignment from today so we can go on into tomorrow and do something else. I haven't got tomorrow's assignment ready for you yet because I'm still making sure we got no questions on today's. So just letting you know. I started a video like using my phone as a video camera and just doing it kind of like I would at the doc cam. And I did a video for the first part of the notes here, and it is still uploading for about 45 minutes now. So I'm not very encouraged by that, and also thinking I need to revise our home internet speed. I don't know, but it definitely works faster at school. So we're going to try this instead. And first thing I want to talk about is what an inscribed angle is. It's an angle formed by two chords that intersect at a point on the circle. So here is a chord, chord AB. Here is a chord, chord BC. Those two chords intersect at point B. That's the vertex of my inscribed angle. So the vertex of an inscribed angle is always on the circle itself. Now what the trick really, I guess it is, to doing problems with inscribed angles is what I was telling you to do for central angles, but it probably didn't make much sense for central angles. Let me go talk about what I mean here. Here is a central angle. It's an angle that has at its center, at its vertex is the center of the circle. So there's a central angle. In a central angle, don't you love my mouse pad drawing here? If this arc is 75 degrees, then this angle is also 75 degrees. So central angle, the angle and the arc are the same. Now, here's the thing I was telling you was sort of a tip or trick. And that is, if you have trouble seeing what the intercepted arc is for your angle, so in this case it's right here, take your pen, pencil, whatever, highlighter, and take the two sides of your angle and make them longer. Make them longer so that they go past the actual circle, so that you can think of these as the two arms of your angle, and in between them, that's your arc. That's called the intercepted arc. That's the arc that's intercepted by that angle. And just like we talked about an interception, the football needs to go between the two sides of your arms. Okay, so for this angle over here, here are your two sides. And I'm going to extend those sides so that it's very clear that the part of the circle that lies between them is right here. Okay, so there's my intercepted arc. That's what that is. AC is the intercepted arc. Angle ABC is the inscribed angle. Now, what we find below here is, unlike this is a central angle over here. I'm going to type that. This is central angle. And I'm going to change my color. This is a little bit easier at the board, but we can do it. There. This is a central angle over here. This one over here is an inscribed angle. On a central angle, the angle and the arc are the same. On an inscribed angle, as you can see a little bit below here, if we scroll down, if an angle, this is the first of three, actually maybe four, little theorems about inscribed angles. And it's really, this is the main one. The other three are sort of, really they're more like corollaries. They're more like those sort of extra facts that come out of this. Like if this is true, then there are certain other little special cases that would be true. But if you have an inscribed angle, then the measure of it is half the measure of the intercepted arc. So what that means is this purple pinkish angle, its measure is half the measure of this arc, the green arc. So if, let's just go ahead and make it the same size. It doesn't look 75, but let's say it's 75. If this is 75, and I just made life harder on myself, didn't I? Then this angle is going to be half of 75, and I'm going to go ahead and, let's see if I can make that a little smaller, or 37.5 degrees. Let's make it a decent color we can see. So how's that? So that's how an intercepted arc and an inscribed angle relate. Now remember that we said before that if you know that one thing is half the other thing, then another way of saying that is the big one is twice the little one. The classic example I use on that is if you are half my age, then I am twice your age. Two different ways of saying the same thing. So that comes in handy when we start writing equations about how these two things relate. All right, moving on. Example 1, find the measure of angle BAC. So I'm going to extend the sides past the edge of the circle. That's the angle I'm looking for. It just so happens that this is the intercepted arc for that angle. That's what they gave me. They gave me this arc, so that's 100. Then the angle is going to be half of 100, which is 50 degrees. I may stop typing degrees at some point here just because it's kind of time consuming to do so. Example 2. The difference here is this time they gave me the angle and they want to find the arc. So here's the angle. Here's one side of the angle. Here's the other side of the angle. And sometimes I write this like on my paper when I'm doing these. Angle equals 1/2 arc. That's the relationship. The angle is half the arc. So you do have to remember which one's bigger. Okay, so the angle is half the arc. Here is the angle. It's half of this arc. The inscribed arc would be right here. So that means that's going to be 20 degrees. So 20 degrees is right there. Okay, in terms of, let me just show you something in terms of remembering which is the bigger one. Let's look at Geometry Sketchpad. I opened this for something else, so File, New. Okay, here's a circle. That is a what kind of angle? BAC. It's a central angle because A, its vertex, is at the center of the circle. So if we know the measure of angle BAC, and we want to know, let's see if I can do the arc measure. I can't really remember how to do arc measure. Let's see. It's probably, hey, all right, we did it. Cool. Notice they are the same. Central angle, arc, intercepted arc are the same. Okay. If you draw the the inscribed angle that intercepts the exact same arc. In other words, if it intercepts the exact same arc, then one side of the angle has to go through B, and one side of the angle has to go through C. So angle BDC is an inscribed angle that intercepts the same arc as our central angle. You can see, just looking at it, that this angle is not as big as this angle here. In other words, this doorway, if you think of it like a doorway opening, it's open bigger than this one here. So if this angle is the same as the arc, that can help you remember that this angle has to be the smaller of the two. This one's the one that's half the arc. And we can go ahead and verify that. B, D, C, measure angle, and it's half the arc. It's exactly half of 52.81 is 26.41. And that's true no matter where it is. Notice that this is not changing. If I changed these, it would. So that is dynamic. That's moving with me. And yet, the fact that angle BDC, no matter where its vertex is, if it's intercepting that same piece of the circle, it's always going to be half. It's always going to be 67.67. Okay? So, let's see, where are we? There we go. So let's look at example 3. Measure of angle A. Angle A has two sides here and here. So the intercepted arc is 160. That means the angle is going to be half of that. So the measure of angle A is 80 degrees. I'm skipping the degrees symbol, folks. It's just too hard to keep drawing it. So now let's look at measure of angle B. Measure of angle B. Here's one side of angle B. Here's the other side. Whoa, a little off the rails there. Here is the other side of angle B. There we go. So here is the intercepted arc for angle B. If the arc is 90, the angle, the inscribed angle, is going to be half of it. So the angle is 40. Okay, now, if I know that angles A and B, let me see if I can get rid of these. If I know that angles A and B are 80 and 40 respectively, then this whole triangle is just angle A plus angle B plus angle C. So that's three angles. They have to add up to 180. 80 plus 40 adds up to 120. So that tells me that this third angle has to be 60. And the two sides of this angle are here and here. So that angle intercepts this arc. So the 60-degree angle has to be half of that arc. So that arc is 120, twice as big. And if I was going to take the time to write all that, I should have written it over here. 120. Oops, I'm sorry, I wrote it in the wrong place. That goes, whoa, okay. I'm just going to erase it then. The 120 goes right here. And this is where the 60 goes. All right, next up. Like I told you, many of these things here are facts that come from that. Here's the first one. If two inscribed angles, all right, in this picture we have two inscribed angles. One of them is right here. The other one is right here. Two inscribed angles. One has its vertex at D, one has its vertex at A. If they intercept the same arc, then the angles are congruent. Well, that kind of just makes sense, because if they both intercept the same arc, then they both have to be half of that pink arc. So whatever that pink arc is, it doesn't matter if it's 100 or 70 or 82, each of these is going to be half of it, so they have to be the same. So that one pretty much makes sense. Next. An angle that is inscribed in a circle is a right angle if and only if its corresponding arc is a semicircle. Okay, so basically that's saying this. If I have an inscribed angle and the intercepted arc is a semicircle, well, then it has to be a right angle, because what's half of 180? Okay, remember, inscribed angles are always half of their intercepted arc. So if the intercepted arc is 180, then the angle is 90. Another way of looking at that same thing is this. If we have, anytime we have an inscribed angle where the two sides of the angle, here's one side, here's the other side, if they go through the end points of a diameter, in this case, here's my diameter. Diameter is AC. One side of the angle passes through C, one side of the angle passes through A. Anytime that happens, then it's got to be 90, because this has to be a semicircle. On one side of a diameter is a semicircle. That whole thing over here is a semicircle. That's 180. So if that's 180, the angle is 90. Okay, I don't think I can go through this last one in the time I've got remaining, so I'm going to cut this video short here and come back to it.